All right, here's my video for problems 45, 47, and 49 from the homework 2.7. I'm going to see how many of these I can get done in this 15-minute window. Sometimes these problems take a little bit of time, especially the problems we're looking at here being the rational inequalities, which means we're going to need to get a common denominator. We're going to set or add the functions together, and then we're going to have to set the numerator equal to 0 and the denominator equal to 0 to see what are the zeros of the function and where is this function undefined, because we know that inequalities can change signs, or functions can change signs at their zeros and at their undefined points. And so in a problem like this, the first step is going to get a common denominator here. And so I'm going to multiply this 2, and I'll try to do it on the side here, kind of as a side note. I'm going to multiply 2 here by x plus 1 over x plus 1 to get a common denominator. And so this is going to end up being x plus 6 over x plus 1. And then I get minus 2x plus 1 over x plus 1. And let's even change this a little bit more. No, that's okay. We'll leave it right here. Okay, I like that. And now I can combine because I have a common denominator. So this is going to be negative x, because x minus 2x is negative x. And 6 minus 1 is a 5. So negative x plus 5 over x plus 1. And now this thing is the thing that is less than 0. Like I said, we need to set the numerator equal to 0 and the denominator equal to 0 to see where this function is going to have zeros or where it's going to be undefined. So I get negative x plus 5 equals 0, which gives me x equaling a positive 5. And the other one is going to be x plus 1 equals 0, which gives me x equaling negative 1. Now I can set up my table to do test interval, test number, and positive or negative. So I get my domain, I like to call it, same thing as test interval, a number, the number I'm choosing, and then whether it's positive or negative. My first domain is going to go from negative infinity to negative 1. So I'm going from negative infinity to negative 1, that first point that I see. And then I'm going to go from negative 1 to 5. And then I'm going to go from 5 to positive infinity. Now in each I got to choose my test interval. For the first one I'm going to choose negative 2 because it's a number in my test interval. Second one I'm going to choose 0. If I can choose 0 I should. And then the last one I'm going to choose 6. Here I have then plugging these numbers back into my function, which I'm going to use my function right here to plug them back into. I have negative 2 plus, negative 2, so that's a positive 2 plus 5, so that's a positive. And then I have negative 2 plus 1, that's going to be a negative. So a positive divided by a negative, that's going to be a negative. Now plugging in 0, I get 0 plus 5, that's positive. 0 plus 1, that's positive. A positive divided by a positive is a positive. And then lastly, 6, I get negative 6 plus 5, that's a negative. And then I have 6 plus 1, that's a positive. A negative divided by a positive is a negative. In this problem, I am looking for things that are strictly less than 0, where we're strictly less than 0 here. And so I'm going to choose the ones that are negative, and that would be this interval right here and this interval right here. And so I have two intervals in my solution. I have the interval negative infinity to negative 1, and I have the interval 5 to infinity. And that would be my answer, those two intervals. Now, looking at another one, what I need to do here, this is now 47, is again, I'm going to subtract over because I want this to be, greater than 0. And so by subtracting over, I get 2x plus 5 minus 1x minus 3 is greater than 0. And again, I'm going to need a common denominator so that I can combine these and get a numerator and a denominator, which eventually I'll set equal to 0. Well, this first one, I'm going to have 2x minus 3, 2 times x minus 3 over x plus 5, x minus 3, so getting a common denominator there, minus the other one, which is going to be 1 times x plus 5 over x plus 5, x minus 3. So getting a common denominator here as well. It's greater than 0. This one, the right term here I just multiplied by x plus 5 over x plus 5. The left term I multiplied by x minus 3 and x minus 3 to get the common denominator. Now, to begin simplifying, I'm going to distribute my 2 in here. This is 2x minus 3 over, again, x plus 5, x minus 3. The subtraction here, and then I get x plus 5 over x plus 5, x minus 3. I can now combine these because I have my common denominator. So 2x minus x, and that's a positive x, correct? 2x minus x, that's going to give me x. Negative 3 minus 5, that's going to give me minus 8. So x minus 8 over x plus 5, x minus 3. Again, I'm going to set my numerator and denominator equal to 0. So I get 3 things being set equal to 0. Now I got x minus 8 equals 0. I have x plus 5 equals 0. And I have x minus 3 equals 0. Each of them, this gives me x equaling 8. This gives me x equaling negative 5. And this gives me x equaling a positive 3. Now I have my x points here. I can set up my test intervals and set up my table. And so I have my table. I want to make sure I can still kind of include this. So I got domain, test number, plus or minus. Well, my first test interval is going to be from negative infinity to negative 5, because that's the lowest x I have. So negative infinity to negative 5. Second interval is going to go from negative 5 to positive 3. Third test interval is going to go from 3 to 8. And the last test interval is going to go from 8 to infinity. Choosing test numbers in each one, this could be negative 6, this could be 0, this could be 4, this could be 9. And I'm going to start plugging these in again. So plugging in negative 6, which I'm going to plug into my function here. Plugging in negative 6, I get negative 6 minus 8, that's a negative. I have negative 6 plus 5, so that's a negative. And then I have negative 6 minus 3, that's a negative. A negative times a negative is actually a positive, so this would be a negative divided by a positive, and that's going to be negative. Plugging in 0, and I'm going to erase my negatives and positives here. Plugging in 0, I get 0 minus 8, that's negative. I get 0 plus 5, so that's positive. I get 0 minus 3, that's negative, and that's going to be a positive times a negative is a negative. So a negative divided by a negative is going to be a positive. Plugging in 4, plugging in a positive 4. I have 4 minus 8, that is a negative. 4 plus 5, that is going to be a positive. 4 minus 3, that's a positive, so the outcome here is positive. So a negative divided by a positive, that's going to be a negative. And then plugging in 9, the last one here. Plugging in 9, I get 9 minus 8, that's a positive. 9 plus 5, that's a positive. 9 minus 3, that's a positive, which the outcome then is positive. So positive divided by positive there, that's going to be positive. In this problem, I am looking for the outcomes greater than 0. And so I want all the positive ones, which is going to be here and here. So again, I have 2 intervals that work. The first interval is going to be negative 5 to 3 and 8 to infinity. And then you have your answer there. A little more involved because we had more x points. We had 1, 0 at x equals 8, and we had 2 undefined points at x equals negative 5 and x equals 3. So it created more test intervals and more work to do, but still just getting 2 answers as my result. Subtracting here now. Okay, same kind of thing. I might not be able to finish this one, but we'll get as far as I can in the next 5.5 minutes. I'm going to subtract over 9 over 4x plus 3 because, again, I want it to be less than or equal to 0. So I get 1x minus 3 minus 9, 4x plus 3 less than or equal to 0. Again, I need a common denominator. So the term on the right, I'm going to multiply by x minus 3 over x minus 3. Term on the left, I'm going to multiply by 4x plus 3 over 4x plus 3. So this is going to be 1 4x plus 3 over x minus 3 4x plus 3 minus, I'm going to multiply this one by the x minus 3, so this is 9x minus 3 over x minus 3 times 4x plus 3. Still less than or equal to 0. All right, time to continue to simplify this until I can get it as one term. This is going to be 4x plus 3, because I distribute the 1 to both terms, over x minus 3, 4x plus 3, minus, distribute the 9, that's going to be 9x minus 27 over x minus 3, 4x plus 3. Now I have a common denominator, and I can simplify the numerators here, put it over the common one. 4x minus 9x, that's negative 5x. 3 minus negative 27, it's like adding there, so that's plus 30. It's like plus 30, that's right, okay. And then I have x minus 3 over x minus 3, 4x plus 3. And this is going to be is it greater than or equal to 0? Less than or equal to 0. Okay. If I factor out a negative 5, it's not going to do anything, can't cancel anything out, so we're just going to go with this. We set the numerator equal to 0, so negative 5x plus 30 equals 0. I get x minus 3 equals 0, and 4x plus 3 equals 0. Doing this one here, subtract over 30, divide by negative 5, you get x equaling 6. Here you get x equaling a positive 3, and here you get x equaling a negative 3 over 4. Again, now we can set up our table with domain, test number, and positive / negative. And we can try to set up our domain again. We're going to go from negative infinity to our point at negative 3/4. We're going to go from negative 3/4 to our point. What's the next closest? 3. We're going to go from 3 to 6, and then we're going to go from 6 to positive infinity. Choosing test points for each, this one can be negative 1, this can be 0, this can be 4, this can be 7. Plugging into our function here is the best bet to make it the easiest as possible. So plugging in negative 1, I get 5 times negative 1, that is positive 5 plus 30, that's a positive. Plugging in negative 1 here, I get negative 1 minus 3, that's a negative. I get 4 times negative 1, that's negative. Plus 3, that's negative. A negative times a negative is a positive. So I get positive divided by positive, which gives me positive. Plugging in 0, get rid of some of these. We're going to plug in 0. 0 times 5 is 0, so 30 plus 30 is going to be positive. 0 minus 3, that's negative. This is 4x, so that's going to be 0 plus 3, that's positive. Negative times a positive is a negative. So a positive divided by a negative is going to be a negative. And it looks like I'll have time to do just one more, plugging in 4. By plugging in 4, I get negative 5 times 4, that's negative 20. Negative 20 plus 30, that's still positive. Negative 4 minus 3, that's negative. Negative 4 times 4 is negative 16. Plus 3, that's negative, so I get negative times a negative, which is a positive. Positive divided by a positive is positive. So you just have one more to test here. This 6 to infinity, you'll be plugging in 7 to test it, and you'll be able to come up with your positives and your negatives. And since we're looking for everything less than or equal to 0, we're going to be choosing the negative terms, whichever those be. Right? Hopefully each problem now has a clear solution and makes more sense of how we solve them. Any more questions, just let me know.